and even beyond that, when you look at the different types of fuels, the energy content varies. If you compare the energy content of hydrogen, for example, that's got the highest energy content, 140 kilojoules per gram. With wood, it's all the way down here at 14 kilojoules per gram. So wood has the lowest energy output per fuel used. And if you think about this, for these methane, propane, gasoline, coal, and wood, these sources are all sources from fossil fuels. Ethanol is what we would consider renewable because it can be grown, or it can be made from plants, for example, corn. And then hydrogen needs to be extracted from either methane, hydrocarbon, or from water. So to get at the hydrogen, it takes a little bit more work than the rest of these. Even though you get a lot of energy back out, it takes energy to get to the hydrogen. But if the reason why the energy content varies is because the energy comes from the breaking of the chemical bonds in the fuel, and so it depends on the energy difference between how much energy it took to make those bonds in the fuels versus how much energy it takes to break the bonds in the fuels versus how much energy is released when it's rearranged in the chemical reaction to carbon dioxide and water. But the bottom line is the energy, for example, for these fossil fuels and even ethanol, everything but hydrogen, originally, and even hydrogen for that matter, the energy originally comes from the sun. Okay, all this energy comes from the sun, and it's trapped in the chemical bonds. Okay, and if, for example, the photosynthesis reaction is the carbon dioxide in the atmosphere combines with water in green leaves as part of photosynthesis to make sugar, glucose, and oxygen. Okay, and to balance that, it's 6 carbon dioxide plus 6 water gives a glucose and 6 oxygen. And in this process, this particular chemical change, this photosynthesis reaction, is an endothermic reaction. It takes 2,800 kilojoules of energy for 6 moles of carbon dioxide to combine with 6 moles of water to give this glucose. And the energy to drive this reaction comes from the sun. Okay? And so the plant material obviously is built up from the glucose that the plants produce via photosynthesis, and then that energy from the sun is stored in all these bonds in the glucose, and then building up into the starch and the cellulose molecules that are the most of the mass of plants. And then, of course, when the plants die, this plant material starts decomposing. Okay, and with heat and pressure, what happens is, as the plant material dies, is buried, and with added heat and pressure, it continues to break down, and giving the oxygen comes off first, and so the older the fossil fuel is, the less oxygen it has. All right. For example, coal. As it turns out, coal, of course, is a fossil fuel. And so the energy, the chemical energy that's stored in coal originally came from the sun, and it is stored in the chemical bonds, and it stays there until those chemical bonds undergo some sort of chemical change, and at which point it will be released. And so there's different types of coal. As it turns out, coal itself is a mixture. It's not a compound, it's a mixture, and so it varies depending on its composition, just like any other mixture would. So it's defined by its composition, but a rough estimate of or approximation of coal is, in your book, they give C135H96O9NS. Okay, that's just an estimate of coal, and in this case, the approximation is about 85% carbon. All right, so starting from the original plant material, which was C6, C6H12O6 glucose, you can see a lot of the oxygen has left the fossil fuel and even the hydrogen, and you're left with mostly the carbon. And of course, nitrogen and sulfur are also a part of living material, and so a little bit of that is left over. And not only that, but there's small amounts mixed in with this coal. There's very trace amounts of sodium, calcium, aluminum, nickel, copper, zinc, arsenic, lead, and mercury. So we find all of these trace elements mixed in with this essentially this rock that is what we call coal. And in this picture here, we have two different mixtures, two different coal mixtures. This one's called anthracite, okay, and this one's called lignite. Sometimes the lignite is called brown coal, and you can see the color is different, and the different color tells us that this one has not undergone as much heat and pressure change. This has a higher percentage of carbon. This has a higher percentage of oxygen and sulfur and other minerals. Whereas this has just undergone more of a heat pressure transformation. All right, and so actually the anthracite is what we would consider cleaner burning coal because there's less other stuff in it, and also it has a higher energy content than the other what we call lignite or brown coal. And you can see here in this table, this is just a list of the different types of coal, the different mixtures that we call coal: anthracite, bituminous, subbituminous, lignite, peat, and wood. If coal comes originally from plant material wood, and then peat is like, it's a breakdown of organic material that kind of in the soil, but you can burn it because it has, a high carbon content, higher than wood, but less than all the others. Anyway, so this is like sort of the grades from the extreme young to the old, and you can see the difference in the energy content: 30 kilojoules per gram for the anthracite, 30.7. So the bituminous and the anthracite are very similar, and then going down all the way down to wood, it's only 10 kilojoules per gram. And the reason why is because on the wood, the peat, and the lignite, there's more oxygen still as a part of those fuels. And remember, when we burn our fuel to get energy out, we're burning the fuel, and we are with oxygen, okay? And then the oxygen is recombining to give the carbon dioxide and water. But if you already have oxygen on your fuel, that's less opportunities to make the carbon dioxide and water, and so it's just a lower energy output for those fuels that have more oxygen associated with them. Okay, so coal is what we would consider a solid mixture. It is defined by the different percentages of the different elements that are in it, and the hard coal versus the soft coal really gives us an indication of how much change the original plant material has gone from the once was living substance with the oxygen, more oxygen, hydrogen, nitrogen, and sulfur, to the older plant material that's been subjected to more heat and pressure, and has therefore, under heat and pressure conditions, already lost off its oxygen and other elements. Okay, so coal is an example of one. The energy content even of coal varies, and the composition of coal varies. That's why, as we saw earlier, when we saw a problem, air pollution problem from power plants, was the sulfur emissions. Well, the softer the coal, the more sulfur there is. The carbon dioxide emissions, it adds to global warming. So, we can see now from what coal is made up to understand where the carbon dioxide, the water, and the other pollutants come from when you burn coal. So there's a lot of policy surrounding coal, the coal industry. How can we make cleaner coal? How can we encourage power utilities to use the cleaner coal, varieties of coal, even though they may be more difficult to get to and more expensive because they're deeper down in the earth. But or if you do use the cheaper coals, how can you clean them up